name is Bill Willoughby. I'm the CEO of Cypress Development Corp. I want to thank you today for this time and opportunity to listen to our talk about our project, the Clayton Valley Lithium Project in Nevada. It's an advanced stage lithium project. We are advanced in the respect that we are just now commencing a pilot plant program of testing, and we are working towards a feasibility study. What we see in our opening slide is a view of our project. We have completed a pre-feasibility study, and in that pre-feasibility study, we would be standing within our open pit, looking towards the west, towards the location of our plant site. Cypress is listed on the TSXV under CYP, and we also trade in the United States under the OTC with the symbol CYDVF. We have 127 million shares outstanding, and our market capitalization is approximately $240 million. We'll skip through the cautionary statements. And we are an advanced project. We are focused on extracting lithium from clay. It is a large resource. We have better than a 40-year mine life in our project with multi-million ton LCE resources and reserves. We have completed a preliminary economic assessment and also a pre-feasibility study. This year, we have completed a definitive agreement for a water rights acquisition, and we are also working towards a pilot plant test program in which we've already completed the pilot plant and we are just beginning our phase of testing. We will then be moving onwards towards a feasibility study and permitting. Our project history with this project in Clayton Valley has been relatively quick. We started in 2016 by acquiring mining claims. We moved then through drilling and metallurgical tests onward into a feasibility study, which we completed last year. We also had at that time success in another leaching approach using chloride leaching. This is now the focus of our pilot plant program. 2021 has been a fast year for Cypress. We've worked quickly towards completing a bought deal financing. That bought deal was approximately $20 million and was completed in March. Upon completion of that, we leased a facility for our pilot plant in Amargosa Valley, Nevada. Our project has advanced quickly from the inception when we first acquired mining claims in Clayton Valley in 2016. We did drilling and metallurgical tests, moved on through a preliminary economic assessment, and completed a pre-feasibility study. Our pre-feasibility study was based on leaching with sulfuric acid. Last year, we started a program of testing with chloride leaching, which we found successful, and that is now the basis for our pilot plant as we move forward. 2021 has been a busy year for Cypress. We completed a bought deal financing, which raised approximately $20 million for the company. That was done in March. We then leased a facility for our pilot plant program in Amargosa Valley, 100 miles southeast of our project. We also leased a 20-acre site near the Tonopah Airport, northeast of our project. That's where we're doing our sample preparation. We purchased our equipment for the pilot plant and assembled it. We did a definitive water rights agreement with another company, which is $3 million, and should provide us with enough water to run our project at the scale of our pre-feasibility study. And part of our pilot plant was that we acquired equipment from a company, Chemionics, out of Canada for direct lithium extraction, or DLE, which is essentially ion exchange. We did that license agreement in July, and that's now part of our pilot plant. This year we raised the $20 million. That's mostly still in the treasury. We have a market capitalization of $240 million Canadian, and fully diluted we're about 150 million shares outstanding. We've strengthened our board of directors. We added Cassandra Joseph as our chair and Brian Disher to the board. We added Bram Jonker as our chief financial officer and Spiros Kakos as our VP of investor relations. Now, I do want to mention here our primary consultant on design and assembly of the pilot plant, Todd Fayram from Continental Metallurgical Services out of Butte, Montana. He's been invaluable in bringing the whole plant together. There are a number of lithium companies operating in the United States. This slide shows the ones that are active in Nevada. Only a handful are at an advanced stage, and ours is the only pilot plant to be using hydrochloric acid and chloride leaching as part of the process. These are Cypress's project locations in Nevada. Our deposit is located halfway between Reno and Las Vegas in Clayton Valley. By Tonopah Airport to the northeast, we have our administrative site and sample prep facility. And then 100 miles to the southeast, we have our pilot plant facility at Amargosa Valley. Our project in Clayton Valley is 100% owned by Cypress. The land ownership belongs to Cypress, but with a 3% underlying NSR, of which we have a reasonable buy down for $2 million to a 1% NSR. This slide shows the results from our pre-feasibility study, which we amended in March this year. These are after-tax cash flow results in US dollars. Our project is robust economics. The base case at $9,500 a ton for lithium carbonate equivalent produced a 26% internal rate of return, again after tax, with a $1 billion NPV at 8%. Our project had a capital cost of under $500 million with an operating cost of about $3,400 per ton for LCE. Again, this cash flow was based on leaching with sulfuric acid. Our project now is moving towards leaching with hydrochloric acid. One common question is, how do the economics change as we move from sulfuric acid to hydrochloric acid? We looked at this closely and found that there was very little change that we could see looking forward, but plenty of reasons for us to move to hydrochloric acid, both environmentally and operationally in handling the material. Another question that we commonly get is, how can we operate a project which has somewhat lower grades than other lithium clay projects? Well, the reason for that lies in our deposit features. It's a thick clay which outcrops at the surface. It's uniform in its lithium grade. It's extensive and flat lying. The clay is soft. It requires no drilling and blasting. And compared to other projects, it has a relatively low acid consumption. We also have potential byproducts in the clay, which include rare earth elements. We have a large amount of resources relative to our reserves. Our resources are better than 1.3 billion tons, grading 905 ppm lithium. Our reserves are 213 million tons at 1,100 parts per million lithium, but that 213 million tons is adequate for a 40-year mine life at 5 million tons per year. In this slide, we see a general arrangement from our pre-feasibility study showing the configuration of our open pit. The pit is shallow and elongate, which allows the use of conveyor transport to the mill. We also are looking at a tailings facility located to the south of the pit. One of the things we will be looking at in a feasibility study as we move forward is whether we can backfill a portion of those tailings into the pit as we mine. In this slide, we're looking at the differences between sulfuric acid leaching and hydrochloric acid leaching. What we see is essentially our flow sheet stays the same. We're looking at the same basic steps of feed preparation, leaching, moving on to filtration, and some form of lithium recovery. When we move to hydrochloric acid leaching, that eliminates the need to truck sulfur to the site. That has its benefits and negatives. On the benefit side, we're eliminating the trucking of raw material, or roughly 800 tons per day of sulfur in the pre-feasibility case, but we also lose a cogeneration power plant. In the hydrochloric acid case, we are now generating hydrochloric acid by bringing just input power into a saline solution, sodium chloride brine, and we're generating hydrochloric acid and sodium hydroxide. The sodium hydroxide then becomes our neutralizing agent in that solution, which allows us to look at other lithium recovery systems than what we did in the PFS. This system also allows us better filtration, better washing of the tails, which should lead to higher lithium recoveries, and also means that we are able to work with a higher slurry density in leaching, which means we need less process water. That was instrumental in leading us to the decision to acquire the water rights agreement that we did this year. Here's our plant configuration that we have in the pilot plant. It's relatively simple. We take our sample feed, run it into a main leach tank, into a thickener. From the thickener, we take our solids and wash them in a series of other thickeners which are running in countercurrent. The leach solution is then treated in a primary and secondary impurity removal step. That solution is then run into our Lionex lithium recovery system, which is the deal that we acquired this year with Chemionics. That solution then moves onward into a tertiary impurity removal step and then recycles back into leach. One step in our pilot plant program, which is not shown on this slide, is that concentrated lithium solution from the Lionex area will be treated in Canada at NORAM Engineering. NORAM will take that concentrated lithium solution and produce lithium hydroxide with it. Here's a view of our pilot plant. Those are the two process water tanks on the right-hand side of the slide. In the center of the photo, you see our green jacketed primary leach tank. To the left of that is a bank of thickeners, which handle the solids and wash them and produce a final tail. And in the bottom left-hand corner of this slide is our Chemionics Lionex lithium extraction unit. We're able to work with this existing gold refinery for the pilot plant. It was a permitted facility. That helped us move forward and move our equipment and arrange it very quickly. We also have an experienced management and staff that was able to help in the assembly of the pilot plant. Our objectives of the pilot plant are to test and confirm the assumptions that we have in our studies, and also to optimize our process. Ultimately, of course, what we're looking for is the total extraction of lithium and how we can concentrate that and make a lithium product at the end of the day. We are also very conscious of our environmental and social presence. We've done baseline studies. Our design in switching our processing approach is oriented towards minimizing environmental impacts, and we're also going to consider renewable energy in the process and how that might work into our eventual project. Our focus has been on effective use of land and water, and we have a commitment in Nevada to working with our local communities to build a sustainable operation. In summary, we have a big project that has robust economics. Our company has been growing this year. Our pilot plant program is just getting underway. It's an exciting time here for the company, and our ultimate goal is to produce a sustainable, low-cost operation. Our upcoming catalysts, we're still working through the water rights purchase agreement. We have a final approval that's required from the state of Nevada, and that will then transfer that water right into Cypress's name. Our pilot plant assembly is complete, and we're processing fluids through the plant right now, and we'll soon begin testing on our clay material. And we're working towards that feasibility study and permitting, which we'll be carrying onward into next year. I want to thank everybody for listening to this talk and look forward to talking to you again. Thank you.